Our next speaker is Ben New. Ben is a student in a master's degree in computer science. His project is titled Imagining Global Futures Using AI for Socio-Political Prediction and Visualisation. His supervisors are Professor Farida Fozdar, who is Dean of Global Futures with the Faculty of Humanities, and co-supervisors are Tama from School of Media, Creative Arts and Social Inquiry, and Alex Jenkins from the WA Data Science Innovation Hub. And HIVE support's been from Doshi.
Thank you, Andrew, for the introduction of my project. So I think we can start directly. Okay, next. Okay, good morning, everyone. I'm Ben, and in this page, as Professor Farida Fozdar put it, universities are places where the future gets designed. The Global Futures is a platform at Curtin University that focuses on creating a better future through research, teaching, and collaboration. The Global Futures platform seeks to build students with a strong global orientation and the skills to set up for the future. It also supports researchers in understanding and solving the global challenges, engages with governments and industry to review public policy and supports academic activities. Now, here is a question. So, how can we use the world's knowledge to build better futures? I think AI potentially offers an opportunity to forecast the future events. AI, or artificial intelligence, especially large language models, has made great breakthroughs recently. Let's explore some examples. Recognizing handwritten digits is a classic example of classification in supervised learning. AI models are trained on labeled datasets to recognize handwritten digits. Image segmentation falls under clustering in unsupervised learning. Unlike supervised learning, the model isn't given labeled data. Instead, it identifies patterns into meaningful segments. AlphaGo is a landmark in reinforcement learning, which involves agent learning through trial and error, receiving rewards for the successful actions. And, okay, generative AI is where AI shines in creativity. Gen AI includes models producing new content, like text-to-text models generate human-like responses, and text-to-image models create visuals from textual descriptions. And the input we entered into Gen AI is called prompt. Okay, let me introduce two remarkable open source projects that help us a lot. Superhuman is a forecasting bot powered by large language models. It can predict the probability of an event happening. Geographical Adventures implements a 3D model of the Earth using real-world generic data. It's a game about delivering packages to different countries around the world. This project accelerates our projects by standing on the shoulders of giants. Okay, this project is a proof of concept to build a global future predictor with visualization. The first objective is prediction, which tries to identify and implement a mechanism for forecasting using AI. This involves Gen AI analyzing information and generating impacts about future events. The second objective is visualization, which tries to identify and integrate the visualization software to image the forecast. Okay, here's a workflow. The workflow is designed to integrate two key components: websites for prediction and a Unity application for visualization. The process begins with user input questions into the front end, and the user can update the prompts or the configurations if they need it. And the backend will query the sources, the relevant sources, and predict the input questions. The prediction is transformed into a structured data set and stored into a database. And the website, the front end, displays the predicted result to the users, and the unit application retrieves the stored data and creates a visualization. Okay, these steps will be covered by the benchmark to analyze and evaluate the Gen AI quality. Okay, this is a demonstration screenshot. Okay, let's check it one by one. That's an input box where users can type their questions, and the setting button allows users to update the prompts and the configurations. And then user click forecast submit button to start the forecasting process. And the backend will search the relevant information using AI to make prediction. And the website also prints the steps of the forecasting process. Finally, the images will be generated following the descriptions generated by AI, like the highlighted paragraph. Okay. This slide outlines 3 key design solutions in our project. The first one is how to answer the questions and generate impacts and images. Here we use the text-to-text AI models to generate queries, and use Super engine to help us acquire sources from Google News. And there's the crawler used to fetch content, and then we need to use text-to-text AI model help us summarize the content of the news. And then use text-to-text model to predict the results, predict impacts. And last, we use the text-to-image models to generate images. Okay, the second one, to highlight the specific countries on our 3D Earth model. We overlay a cover layer that matches the shape of the country. This layer is positioned above the actual map with a small gap, because we need to handle the difference in altitude. And this design ensures that the highlighted country stands out clearly. Okay, the last one about the transition between different countries. We moved the camera position instead of rotating the whole Earth model. By adjusting the camera's coordinates, we can guide users from one place to another place. Okay. During the transition, during this project, we encountered several challenges and gained valuable experiences. One of the biggest challenges was managing the randomness in large language models. We addressed this by adjusting the parameter named temperature, which controls the creativity of the output. We followed some good experiences in prompt engineering to get the ideal output, like structure the prompt and repeat the keywords and specify the output format, and using a multi-shot prompt and of course chain of thought (COT). Okay, the accuracy of forecast is another critical challenge, and we list these tasks to follow up in the future. And there are some issues about the input-output, and especially for the log context and content. So we can use in the content compression and the content summarizing to shorten the input. For the visualization, quantitative data is more friendly, but unfortunately, it's difficult to generate the quantitative data by Gen AI. So now we use the qualitative data to visualize. Okay, next I want to share some interesting findings. The first one is about the text-to-text models. Okay, it looks like Cloud 3.5 is smarter than ChatGPT 4.0. Right? And we asked the models to generate impacts for the questions, what would happen to global movements of people if all national borders restrictions were removed. And okay, here's output. On dealing with the token size limitations, and Cloud 3.5 works better than the ChatGPT 4. Okay, please check the highlight part. You know it's a very long output from the Gen AI model, and you will find that, okay, the Cloud 3.5 will provide a completed JSON format output. And also, it gives a note mentioning that, okay, it's a long content, but it needs to cut down some or summarize some important information and leave more information left, okay? But for ChatGPT 4.0, okay, fortunately, it cuts the output directly, and it break the output format, the JSON format. Okay, the next demo is about the list countries for the specific regions. Okay, please check here. Because we need to highlight the countries in our 3D model, so that means if the output is a specific region like European Union, that means, okay, I need to know which countries will be included in the unit union. So I ask AI model to help me generate the countries, list all of them. But ChatGPT 4 sometimes cannot give this answer. You see that the red one, there's a countries with a country list. But the left one, okay, lacks this information. Okay. The next one, we compared 3 text-to-text image models. They are DALL-E, Bria, and Firefly. And we use the same input prompt to generate images. And images maybe have the similar quality. I know it depends on different people. And some of them provide interfaces with web UI and API. And for the pricing, Brand provides limited free credits. So for our project, our initial solution is Brand because of the free API support. Okay, we also explored retrieving information from different sources, especially Google News and Google Scholar. Google News Google News proved to be a valuable source for timely and current information. It's highly accessible and provides a wide range of articles on trending topics. However, the content is often less rigorous and more journalistic. On the other hand, Google Scholar offers high-quality, peer-reviewed, and academic content. The sources here are more credible and provide deeper insights, making them better suited for rigorous forecasting and research. However, we encountered a challenge. Retrieving the content from Google Scholar is much harder due to the restrictions on web crawling. And academic papers are often behind the paywalls or require special access, so making it difficult to automate the extraction of the full context. Okay, here are the milestones we set for the project over the past 10 weeks. As you can see from the table, most of the planned tasks have been completed. But of course, there's a few optimization tasks will be carried to the next phase. Okay, in conclusion, Our project demonstrates that it is possible to predict the socio-political questions and visualize impacts. And however, we also recognize the current limitations and the future improvements. Okay, the limitation now includes we only support the geography questions because of the visualization solution based on a global map. And the image generated by AI is not good enough. And there's no quantitative data to visualize, no VR experience. I know VR experience is applied rights for the human. And of course, we don't set up the benchmark right now because of the time. Okay, so for the future work, we'll change to sources from the Google News to scholarly papers and set up benchmark and enhance the visualization. Of course, VR experience is very important for us. Maybe videos, it will be a great idea, I think. Okay, I would like to extend my heartfelt acknowledgements to everyone who contributed to this project. Primary supervisor, Professor Farida Fozdar, HIVE supervisor, Dr. Doshi, and Dr. Michael Evans. Co-supervisors, Professor Tama, Mr. Alex Jenkins, and open source projects, Gen AI products, and cloud services. And a very special thanks to Curtin HIVE and the Curtin University Faculty of Humanities for funding this project. And thank you. Question time.